welcome to our webinar with Data Center Network News and CRH. My name is Joe. I am the assistant editor on Data Center Network News, and I'm going to let all of our panelists introduce themselves. So let's start with who have I got here? Let's start with Thomas.
Hey, good morning, everyone. Thomas Donahue, Vice President of Strategic Alliances and Innovation for CRH Group.
Okay, thank you. And France?
Hi, I'm Frans Vreeswijk. I'm Vice President of Customer Solutions here with CRH Americas, based out of Atlanta, and I oversee some of the new solution concepts that we bring to market. And in that, I work closely with a lot of our customers and key stakeholders from across the value chain, just to make sure that we always address the challenges that they're facing.
Perfect, thank you. And let's have Jennifer.
Hi, everyone. I'm Jennifer Sabetti. I'm the Vice President of Product Strategy for Oldcastle Infrastructure, and I am also based in Atlanta.
Perfect. And Janessa.
Good morning, everyone. My name is Janessa Milieta, and I'm the Vice President of Sustainability, Innovation, and Customer Solutions for our Great Lakes Division with Americas Materials.
Super. Thank you so much, everybody. So we are going to get right into it. Just to let you know, those of you that have joined, we will be having a Q&A session at the end of the session. So if you do have any questions, please put them into the chat and our moderator will fire them over to me and I will get them to the panelists at the end of the show. So let's get started. Off we go.
Awesome. Thanks, Joe. Well, first of all, really excited to be here this morning, and thanks for everyone for making the time to connect with us. We have a great panel, as you heard, lined up that represent decades of experience across the building construction industry, and it's exciting to be here. We'll be discussing a lot about data centers. As many of you will probably know, the number of data centers that are being built and being constructed is just astonishing, right? The estimates and the numbers, they vary, but what you read in the news every day is that billions and billions of dollars of capital are being allocated to the construction of these large data centers and all of the ancillary infrastructure that goes around them. A recent study by BCG, which really resonated with me, was that they forecasted that more than 100 gigawatts of energy would be needed in 2030, which is equal to around 100 million houses consume energy today. And to put that in perspective, that's around 2/3 of our house base in the US at the moment. That's just astonishing, right? So it puts a lot of strain on our existing infrastructure, and it really makes us reinvent and rethink how we're going to construct the infrastructure of tomorrow to support all of these data center build outs that we're seeing and that we've in the pipeline. And so on that, I think it's great that we're here together today. We'll be zooming in on a lot of the new innovations and trends that we're seeing come in the market. As I said, we'll really have to rethink how we do some of these things and reinvent current processes, methodologies, come to the market with new products and new solutions, which is a super exciting time for all of us. And maybe just to kick us off with that, Thomas, the first question I have for you is, given where you sit today, right? You mentioned you're part of, you're forming strategic alliances with a lot of our industry players. You track all of the innovations that come in the market. Could you elaborate a bit of the innovation and trends that you're seeing in the data center space?
Yeah, absolutely. Thanks, Franz. So I think you already touched upon this. The scale of data center construction is unprecedented across the construction value chain. But what we're really seeing is that investment surge. So if we take the top 5 hyperscalers as an example, they're projecting somewhere in the region of 750 billion in capex in 2026. Now, 75% of that approximately is tied to AI infrastructure. And one of the metrics that I track and we talk a lot about with our partners is around every gigawatt of data center capacity that is brought online, it's driving somewhere in the region of about 42 billion in capex investment across the supply chain. And that's from silicon to structure, right? So if we look specifically at construction, what we're seeing is about 15% of that spend is directed towards construction activities. So that's about $100 billion flowing into the built environment for data center construction in 2026 alone. And with respect to trends, I think there's a number of different trends that we're tracking that we're seeing. But if I was to boil it down to maybe four primary trends across the construction value chain, I would say that it is energy, water, site complexity, and time to market. Now, if I take each of those in sequence, so energy, what we're seeing from the US data center electricity demand is that it's going to exceed 250 terawatt hours this year. What that means for, I guess, the broader value chain is that the compute demand is now hitting a so-called soft wall, right? Where we have insufficient generation and transmission. That's driving a trend in innovation. Now, hyperscalers particularly are starting to invest in small modular reactors, alternative forms of energy, behind the meter solutions. And we're seeing gas interconnection requests up about 160% year on year. So energy is a real trend that we're all acutely familiar with. The second trend is water. So I think back in 2023, it was estimated that about 17 billion gallons of water were used for cooling data centers. That's projected to double or possibly even quadruple before the end of the decade. So that's particularly important because two-thirds of data centers that are being built or developed over the past number of years, they're in places where there's already acute water stress. So this is driving, again, innovation in closed loop systems, in direct-to-chip liquid cooling, and even in alternative solutions for cooling like seawater, such as with the Start Campus project in Portugal. Adding to that, you have a trend around managing the water also. So we see investments in innovation for AI-driven leak detection, for water management. It's becoming more and more prevalent. The final two are site complexity and time to market. So the trend around site complexity is particularly interesting. The easy sites are gone, right? Operators are being pushed to more remote locations. They're less developed geographies. The existing infrastructure is not as developed. So what we're seeing as a trend is an increase in the need for soil stabilization, grading works, advanced civil works before you actually build the data center at all. And this is important because the stats we see from companies like Cushman and Wakefield is that the average land parcel is now somewhere in the region of 224 acres. So these projects are getting larger, the site footprint is getting larger, and they're in more complex locations. Add to that the demand for materials. So the American Cement Association is estimating that data center projects, they're going to consume about 860,000 metric tons of cement across a 3-year period. Again, this is driving a trend in innovation for delivery models. So more of a transition to offsite construction techniques with attempts to compress timelines, but also introduce technologies in the digital vein. So the use of sensors, the use of digital workflows, and then finally, trying to reduce the demand on virgin materials. So we're seeing a trend in the transition towards supplemental cementitious materials, bio-based materials, and really trying to drive that adoption to meet performance, but also help customers meet their climate targets. The final trend that I spend a lot of time talking about with different customers and partners is time to market. So historically, on a 60 megawatt facility, you would see a delay of a month costing anywhere between 10 to $15 million. That pressure is cascading to every stakeholder in the value chain. And so these historical 12, 18-month bills, with the transition to these AI campuses, that's no longer feasible, right? We're seeing these large multi-year programs, 2, 3, 4 years with big interconnection timelines. And so construction is often having to move up and commence before design is fully finalized. So that's driving a tension between scope with different parties. And so all of that is then compounded with the last point, which is the availability of skilled workers. Typical project sizes were, they had workforces of maybe 750, 800 people. These AI campuses are projecting 4,000, 5,000 of a workforce on site, coupled with, the constraints in the environment in the industry today, where an additional 500,000 workers are needed. This is now again creating additional tension. And so the innovation again that we're starting to see through the value chain is around early stage engagement. So trying to move that conversation earlier in the process, de-risk construction, think about what elements can be pre-planned, pre-produced off-site, and ultimately how can you drive some front loading on the logistics planning and on the delivery execution. So that's just a snapshot of some of the big challenges and trends that I'm seeing in the industry.
Thanks, Thomas. No, really, really appreciate that. And I think some of the things you mentioned there really resonate. You talked about earlier engagement with some of the key value chain players, right? Could you maybe talk a bit more about how you, as a building materials provider, right? What is it that you're doing, and how are you partnering with the key players in the value chain?
Yeah, look, I think the touching on the challenges again that I just described, so energy, water, site complexity, time. The reality is that none of these challenges get solved once the data center is operational. So they have to be solved at the very beginning of development. And what that means is it's a change in how you plan, design, and then sequence the infrastructure build. So the way we think about it is, every data center has four construction phases. That's the subsurface, the at grade, the building, and the finishing. What that means is that a delay in any one of these will cascade through the others and ultimately into operations. And so the way we've been approaching this, and I think it's a good practice for the industry, is through early engagement. And what I mean by that is we're having conversations with designers, with contractors, and with developers during the planning stage. So not post-award when decisions have already been taken. The reason this is important, and I think one of the things I would try and impart on the audience, is that our scale matters in these conversations. When we look at North America, we have more than 2,000 locations across both the US and Canada. And when you start to talk about time constraints and supply certainty, that's one of the key priorities we have in those conversations. Adding to that, I want to share one additional point, which is around the work we do with owners and developers to help them also innovate these performance solutions. So we have access to a $250 million innovation fund that's helping us explore alternative binders, AI for mixed design optimization, and helping really our customers to drive alternative delivery, more certainty of outcome, and ultimately de-risk the delivery of their data centers. So I think to summarize it, the model has shifted from kind of a quote and ship approach historically with the supply chain to a more integrated delivery model. And I think it's for the better.
Yeah, no, completely agree. I really like how you walked us through that, and I think we now have a picture up on the screen that kind of zooms in on that, first phase of construction that you talked about as well, right? The subsurface infrastructure that's required for these data centers. Jennifer, given where you sit, you work with Oldcastle infrastructure. Could you maybe talk us through some of the challenges that you're seeing when we look at the underground infrastructure of data centers?
Sure. Thank you for asking. So I think that Thomas did a great job of explaining how our partnerships to understand the customer needs, as well as our deep understanding of how the construction timelines work, how the construction project success is measured, is really part of what enables us to be such a great partner in this project. So there's a lot of challenges he highlighted. I thought that he did a great job of explaining how the precast solutions for those at grade and underground enclosures are optimized for this solution. The earlier we can start working with customers to understand their needs and their desired outcomes for the data centers, the better that we can custom design these enclosures solutions for their data centers. The earlier that those conversations start, the better, because there's so much really intricate planning that goes into that site preparation. And we find that the better we understand the customer needs, the better we can design a solution that's going to reduce that installation time. It's also going to make all of the enclosures, all of the water projects, all of the cabling on site safer to install, rather than having to have all of that specialized labor that you talked about. We can actually prefabricate all of that in a custom manner, so it requires significantly less labor and it's significantly safer to install. Thomas also mentioned that, we're looking at the energy consumption and water consumption needs of the site. So it's important to think about all of that water and all of that energy management from day one. Typically, these sites require a lot of both of those resources. A substation may be also installed on site. So the more that we can combine those two design elements as we're helping the customer to create these solutions, the better we can address their site constraints. Thomas had addressed some things about the site constraints for these data centers as all of those first choice optimized locations are taken. A lot of data centers have really limitations on their space. They might have a smaller footprint. They might have a phased campus planned for them. So all of our custom design on these enclosures, on all of the at grade or below grade solutions, can really help to eliminate stockpiling all of the material on site. I mentioned the staging of those large crews. Whenever you have custom work or a lot of really heavy equipment on site, you're going to get in the way of some of their other construction timelines and some of their other equipment that they're bringing in. So all of this, we help them with that just-in-time delivery, the modular components installed in that minimal footprint. And we provide a custom installed, so it ensures that customer success. And one of the other challenges I think we see too, that the custom, the project approach, this partnership with the customer, really helps us to monitor our quality. Because we're manufacturing these thinner, lighter, safer products, we're managing our quality process on site. We're taking that quality integrity to the customer location as well. So we're providing the consistency on both ends. We're pre-testing all of our components, and we're eliminating variability. So you're not going to have weather or other site challenges impacting the install or impacting the quality, because we've eliminated that risk with our custom engineering, with our technical expertise, and with all of the monitoring that we do to make sure that those products are perfect before they get to the site.
Awesome. I love it. It sounds great. And I think you touched on, I think just by listening to you, right, you really focused in on some of the complexities that come into play here. And I like how you're trying to streamline some of these processes with, on the one end, the installers, and the other end, the engineers, as you can go through these data center projects. Could you maybe talk a bit about some of the innovations that you're seeing, right? A lot of what you do is underground, right? So I can imagine there's innovation, but maybe innovation that, we don't typically see. So maybe you could talk a bit about that.
Yeah, absolutely. So I think there's some really important things here. The main thing that we focus on is understanding what the customer is going to need once it's installed. A lot of our customers are going to phase their campuses. They're going to need to increase the capacity for their subservice fiber, their fiber integrations and their fiber installations. So we make sure that we're providing them solutions so that they can add new cabling from a substation to their data centers, and then in subsequent data center builds. We make sure that those are all accessible. So rather than bury something, deep underground that you're going to have to completely disrupt the entire site, rendering it, the campus inoperable to get to that, we make sure that they can get to their cabling as needed. An additional innovation in that space is that some of our customers need their cabling to be extremely secure. So we will partner with our customers to understand the level of security that they require. Data centers are already a very secure space. We consider the perimeter access to the data center as well as access to the building and access to the assets in the ground. So depending on the customer's desired level of security, we can design custom multi-tiered security systems for all of their fiber to ensure that they have the level of control over access to the entire site or to specific components within their enclosures. That's something we're really proud of. I think, you know, it isn't something that each customer is going to require the exact same thing, and our technical expertise allows it to be customized for their own level of security requirements. Some other really exciting innovation is in the water space. We are working on and offer AI leak detection technology that we're expanding. This will help customers to identify where they have leakage in their water distribution system. So one of the key parts of the data center success is that consistent access to water for a variety of reasons. And so by making sure that we're not only detecting leaks, but anticipating the potential breaking points for that water infrastructure, we can help them with preventative maintenance. We can help them make recommendations on ways to make that installed water infrastructure more resilient, respond to a potential leak or a potential water loss event at their site. So we're working on that because we don't just want to protect one aspect of their installed infrastructure. We're really looking at how to service their entire installed infrastructure base.
Thanks. I love it. It sounds amazing. It's so funny because when you look at the underground infrastructure, you don't always think of all these different elements, right? But there's a lot of innovation going into that space. And I think to the point
Absolutely.
that you raised and that Thomas raised earlier as well, right? It's all about how do we get these data centers up and out of the ground as fast as possible. And some of the precast solutions you touched on are instrumental there. So thanks for that. Maybe we can
Absolutely.
shift gear and kind of look at kind of like the next phase of the site construction, right? And Janessa, maybe you can walk us through some of the trends and innovations that you're seeing when we look at the next phase of constructing a site.
Yeah, thanks, Franz. I think when we're thinking about this next stage and the challenges that present themselves, we really need to take a look at material availability and supply, and also the remote nature or the semi-remote nature that we're starting to see where these hyperscalers are developing data centers. On the material side, we're talking about hundreds of thousands of tons of materials, from aggregates to asphalt to concrete. And that has a bunch of implications, not just from a sequencing standpoint of when we bring material to site, and logistics definitely plays a part of it, but also on capacity. So where are quarries located? Where are asphalt plants located? Are the partners that we're working with, are they able to have mobile plants and production on site? And those haul distances for bringing aggregates in, what does that look like? And all of that plays a huge role because supply ultimately becomes a critical risk path if that's not locked in immediately. It's one of the biggest constraints or challenges we have when working on these sites. And then when we bring in timing, the downstream trade sequencing is extremely impacted. And it can, stall a bunch of activities, as both Jennifer and Thomas mentioned. So we really need to, resequence around different weather patterns, plant capacity, haul constraints, even in particular, the permitting challenges or the site specific and regional specific requirements where some of these sites are. Workability and temperature comes to play with that as well. We can't always have material availability or production on site unless the right weather window comes open. And so we really need to adapt to all of those site constraints. Now, the last piece, and I know I just touched on it briefly, is kind of that remote nature of the sites. And the remote nature doesn't just impact material availability and logistics on site, it also impacts the type of properties that we're working and developing with these hyperscalers. And some of them are not necessarily, the ideal spot to set up these locations. There could be increased water infiltration. There could be soil stabilization challenges that we have to work through. And that means that working with the appropriate partner at those early stages, when the site development is really happening, is going to create the foundation for us to lay the appropriate paths, the appropriate asphalt, and in addition, create that substructure for the data center to really function and exist.
Yeah, I think that makes a lot of sense. You touched on some of the, say, remote locations, right? Or, building a data center out in a more rural environment that is, not yet connected to the grid and not yet connected to the water. I think it's interesting because I think one of the things that we discussed before this call as well is, CRH, because of, the broad network and the very local character of our business, right? That typically allows us to help support our customers even in these very remote locations, right? Having said that, one of the other things I wanted to discuss with you, because you talk a lot about a lot of the materials that are being used in the build of these data centers. A lot of the hyperscalers we know are on net zero pathways. Could you maybe talk a bit about, how sustainability comes into play and how you're supporting, lowering the carbon footprint of some of these data centers as you build them out?
Sure. Thanks, Franz. What I want to start with is just a sentiment that really to reduce carbon impact, it does have to start in the design phase. That's where we need to kind of lock in these foundations and choices. And it has everything to do with performance specifications as well as quality and material availability. So right now, at least from the material side, and I'll probably shoot it over to Jennifer at some point to also talk about the product sector. But what we're trying to do is increase that circularity in our materials, particularly in asphalt. So with asphalt, we're seeing higher percentages of recycled material utilized. We're trying to use warm mix additives or bio-based binders to really increase that embodied carbon reduction that's possible on site. When we take a look at concrete, right, the use of SEMs, we can reduce cement usage. And then we pair that with things like optimized gradations, curing plans, thermal modeling to make sure that we're trying to reduce the amount of energy that's going into the construction of these data centers as well. So we've got a large amount of substitute products that fit a high carbon reduction system. And that's just on the material side. That's not even to when we get to the precast and the actual substitutions we can see in trenches or duct banks or even composite or modular systems. And then the last part of that is also logistics and rework. I think it's an area that's usually missed when we talk about carbon reduction, is just having to redo the work that we've already put forward and the haul implications of where these materials are coming from. All of those also play a part. And the more hands we touch or points in contact we touch, the increased carbon impact we have. So working with a partner that can sequence and put everything together in a way that's managed to reduce rework, minimize haul distances, and also create material mix designs for these data centers that have a reduced embodied carbon. That's all pieces of the puzzle. Jennifer, this might be a great time if you want to jump in and talk a little bit about how we're swapping poured in place trenches on the material side for things like our stack of boxes and our different trench systems.
Thank you, Janessa. I think you explained that and set it up beautifully. So, we are, with all of our technical expertise and our product breadth, we're always looking for ways to improve our environmental impact. Am I echoing for you guys?
Yeah, just a bit. Let me try it again.
Okay.
It's okay before.
All right. Tell me if you guys can hear that as well. Apologies.
Yeah,
so
we fixed the issue.
Thank you. So I was saying Janessa explained that and set that up beautifully. And so we're really trying, as part of our product strategy, trying to understand the full environmental impact of all our products. So when we are involved upfront in that design partnership in that design phase, like Janessa said, we can make early decisions about what types of materials, what types of manufacturing processes would optimize the outcomes for the customers. For example, we have huge scale and technical expertise in a variety of materials, including our composites. So we work to understand what materials are going to really drive the performance needed for the data center. Whether that's on that substation side and we're looking at the energy management aspect, energy production and energy transmission, or whether we're looking at the actual performance of the data center, we can make material decisions very, very early in that design. We can make manufacturing decisions very early in that design to pick the correct amount of material, the correct type, the correct process that's going to make the products stronger, lighter, and safer in the design phase. So then once it's being installed, we can fit into that installation schedule, into the construction schedule. We can look at ways to value engineer and design some of the weight out of the product depending on site needs. We can look ahead at what type of filtration is going to be needed for the geography that we're working in, that the customer is working in. What are the environmental requirements of the location so that we can make sure we're addressing that up front, guaranteeing the performance. And all of that is really, important so that we can optimize it for the load rating and for the actual the specifications and outcomes that our customer needs.
Thanks. That's a great addition. Maybe back to you, Janessa. Could you talk a bit about some of the innovations that you're seeing in this space from like a
Sure.
material perspective?
Yeah, no, I mean the innovation space is kind of ripe in this market at the moment. And it really is also about value engineering and putting our technical skills to use dependent on the performance requirements that we need. We're seeing everything from carbon sensors, which are embedded sensors for temperature maturity, for curing time. This also reduces the timelines we're working with. And I mentioned it earlier, sequencing is a really big factor. So when we start taking innovations that also optimize that sequencing, it has a huge impact across the production and the development of these sites. And that's even touching back on the carbon side, right? The next generation material advancements that we're seeing come into play are numerous in nature, anywhere from carbon mineralization and carbon injection to the use of SEM optimized concretes, nano enhanced bio admixtures. These are all things that are in development. And I think what we probably should touch on is the fact that large organizations and ones that operate across the value chain, they're also right now, embarking on very, very beneficial partnerships with educational institutions and other partners in the construction and road space. And that is to make sure that these advancements continue to be defined and continue to move forward. And Franz, I would be remiss to say, when we think about innovations, we always think about the material side or the product side, but the safety side is also critical. And when we innovate, it's also about keeping our crews safe and keeping the individuals on the site or our partners, employees safe as well. And that's from anywhere from monitoring of our sites, that's from early detection, that's for maintenance mitigation, and that's ensuring that the tools our businesses are working with, even from a plant perspective, all are advanced, have metrics, have monitoring capabilities, and are ensuring that they're technically fit for work so that our work and what we're doing is fit for purpose. And I think that's a big distinction that I want to make sure is that safety innovation below ground and above ground, whether it's modular material based, is critical.
Thanks. No, appreciate you raising that. Safety is definitely our first and foremost priority. So it's great to hear that we're also innovating in that space, right? To make sure that as we, face increased, timelines and we want to speed up processes, we don't lose sight of the most important part there. So that's much appreciated. Maybe we can move to the next phase, right? So I think we've now discussed on how we kind of get up and out of the ground. Thomas, maybe you can talk about, once we start constructing the building itself, right? What are some of the innovation and things that you're seeing and that you're, collaborating on mostly?
Yeah, thanks, Franz. A few areas I think that we're seeing some movement around in the construction phase. So the first is to do with heat, right? So heat is reshaping the building. And what I mean by that is that AI hardware today is generating, 3x the heat output than a few years ago. And on top of that, we see rack densities are up. And so from the construction and envelope side of the building, we're seeing insulated tilt up and precast sandwich wall panels are now becoming standard spec. And ultimately, what that means is the envelope is moving to represent a thermal management system. Now, add to that, you've got heavier racks, you've got liquid cooling, which is driving thicker reinforced slabs. So the tolerances around that are pretty precise. We've got heavier piping runs, and in some cases, you're seeing these multi-floor plans to handle the weight. So there is a lot of innovation and change happening in the way the building is being constructed. Another point is around security. So security is now morphing into a structural decision. So the physical security spec on these buildings, and Jennifer touched on this for the below grade aspects, but it is getting closer to government facilities. So you're seeing ballistic resistant precast walls, blast barriers. You're seeing, anti-ram perimeters on all parts of the building package. So security really is becoming paramount, and being able to develop and install that effectively is a critical part of the construction process. Um, Two other thoughts. I think one is that offsite is now really changing the delivery model. So the conversations I'm having with designers, with contractors is that they're trying to design to move that scope offsite and put it into a controlled environment, so a factory environment. And this helps with many things around precision, quality, but also safety, and picking up on what Janessa talked about. So these are things like your precast panels, your modular assemblies. Again, this is important because if you have these AI campuses that need 4,000 workers at peak, and you're seeing a national labor shortage, any delivery model that can optimize for the on-site trade requirement is going to be a competitive advantage, and it's going to de-risk the delivery of these very complex projects. The final piece, I think, is around smarter engineering, and Jennifer touched on this, right? You have smarter engineering on the product side, then you're going to be able to develop and deliver these builds faster. One of the things we've been looking at is how do we apply AI and machine learning to the development of panel engineering. So within CRH, we've been using it to optimize both the brace and connector placements on tilt-up walls. And so the idea behind that is that you get the shop drawings out faster, you have fewer errors, you're reducing the potential for clashes or conflicts at site. So again, protecting that schedule, developing more certainty of outcome. And Janessa talked about the types of sensors that are being embedded in the pores. The the benefit or the value that's being created here is that it's giving real-time data. And so that's hyper important for these GCs who are stripping the forms. Can they get that done earlier? Can they change the sequencing of the work? Can they keep the scheduling moving? So all of this is sort of under the umbrella of smarter engineering to enable faster builds. There's just examples of some of the things I'm seeing with our partners on data centers during the construction phase.
That's awesome. Thanks, Thomas. I really like how you laid that out. Again, I think a recurring theme is how do we speed up, the timelines, and how do we, make sure that we collect the data and support the contractors in getting these buildings up and out of the ground as fast as possible. Some similar challenges. When we move to the final phase of the data center, right? Janessa, are there maybe some other trends that you're seeing or other developments that you're seeing there, or the recurring themes of time and speed prevalent in this phase as well?
Well, I mean, it goes without saying, all the different trends that we touched on, you're still going to have in the finishing stage. But I would say there's probably two unique characteristics when we look at finishing. One is aesthetics. I mean,
Right.
we're not operating in the time of big gray boxes, right? These data centers are campuses. Sometimes they're very close, as Thomas mentioned, to government facilities, to our neighborhoods, to where people are living. And we also want to make sure that these data centers are blending into neighborhoods. And so when we talk about finishes or the appropriate finishes, we need to look at it from an architectural lens, not just from a construction lens. And things like, investments on green infrastructure, we're seeing that come to play a lot more than we ever have before. That impacts the masonry products we use, the fencing we use, the natural aesthetics that we build in. And when we partner with hyperscalers and we start looking at the design from the very start, those implications and those parameters we also take into account from a finishing perspective. The last thing I would leave with you, Franz, is the work's really not done as when the building envelope is complete. It is all about the maintenance of that building after. So there's a lot of construction efforts, quality efforts, and maintenance efforts that go in with a true partnership with a large scale partner to make sure that that's maintained and that it's resilient. We're talking about resilient design, resilient buildings. And it also comes into play durability in extreme weather conditions. These data centers, they aren't afforded the opportunity to go down. So the type of design we do not only has to be aesthetic, it has to be resilient, it has to be durable, and ultimately has to complement the environments it's in. So that would be probably the predominant additional trend you'd see towards finishing.
Yeah, thanks, Ines. I appreciate that. I think that resonates, right? When you think about building a durable and resilient data center for the future, it starts with the engineering upfront, but equally important is the maintenance afterwards, right? How do you maintain that building so it's there for a long time? So I think that resonates well. Maybe as we wrap it up, I think this has been super insightful as we've kind of gone through these 4 phases of construction. And we touched on many different things. Maybe I can ask you all to kind of just, we've come up with one quick anecdote that really resonated with you as you've been working on these data centers that really highlights how collaboration from the start has made a real impact. And I don't know if we want to start with you, maybe Thomas.
Thanks, Franz. Look, the conversations that I have, the partnerships that I form, a lot of it is centering around complexity and scale. These campuses are getting bigger. The level of coordination and interface is increasing. The potential for adverse outcomes increases exponentially. And so I think the way to mitigate that, and my takeaway is that early engagement, and that's not just a conversation, that's sitting at the table as partners, understanding capacity in the supply chain, understanding innovations that can help you achieve outcomes, that can de-risk delivery. All of that, if that can happen earlier in the process, then I think it's going to drive the ability to deliver the huge investment that is being committed, not just by the hyperscalers, but across the board. So that's my takeaway, my little reflection from what I'm seeing in industry.
Awesome. Thanks for that, Thomas. How about you, Janessa?
Franz, I mean, I'll give you an example. I think if we think where we've come on data
Right.
centers, a few years ago, I heard a story that we had a project in one particular area of the United States, and our buildings team was really, really focused and centered on it. And a few months trickled by, and the project was developing, and we later learned that our materials division had also been involved, but at a different stage of construction. And today, when we fast forward that, there isn't that disconnect. The amount of communication and collaboration we're seeing when you have partnerships with capacity and capabilities across the value chain is this build faster and de-risk of construction when all areas of the build are brought into homogeneity opposed to siloed working operations. And I think that's a critical factor and a critical success success indicator that we're seeing now. When we look at data center construction, when we get involved earlier in the stage, when we bring on board all the different key elements and products, specifications and parameters, and we start communicating and collaborating on that basis, that's where we're starting to see the capabilities increase, the ownership costs reduce, and ultimately the risks for the entire production and construction of the data center be reduced.
Awesome. Appreciate that. And maybe finally, Jennifer, I know you partner a lot with a lot of players across this in the world, from engineers to owners, developers. Maybe you also have an example of where you saw that the early customer engagement was really able to solve a customer's challenge.
Well, I think to Janessa's point, the work that we do, the work in the data center construction space really exemplifies critical infrastructure. It's
Right.
critical to our customers. Like these outcomes of these huge projects, are sort of on a knife's edge. There's so much attention on them. Sort of the economy of our country is really centered on these things right now. We see so much visibility in this space. It elevates the criticality of getting it right. And that is just a huge pressure. There's pressure across the board in each one of these jobs, and a lot's riding on this for the residents of where they're based. It's like a local impact. So, it's critical to the environment. I think we're seeing a lot of examples where we have to design the data center to really protect the assets, the critical water access. So, we are seeing a lot of examples where we have the opportunity up front to design non-potable and reuse water in their infrastructure designs from day one. So you can separate these purple pipe systems, but a lot of times the water still needs to be, heavily treated. So how do we make sure that we're doing that? So that the residents and the local environment is still protected. Going back and retrofitting would be really disruptive, potentially facing larger local challenges. And so planning it up front really makes that critical install work once for the owner, work really well for the local residents. And it's critical from that standpoint as well in terms of water quality and water access. And I think the final point that we've kind of touched on in a bunch of different ways today is that it's critical to the workers, the site workers, our employees, and to anybody who's coming in contact with our products, out in the installed world. Safety is really the main consideration. How do we make our products safer to make? How do we make them safer to use, safer to install? And so anybody that comes in contact with any of our products, with our materials, have we really considered that safety impact in the entire value chain of manufacturing and for that data center to ensure that the critical infrastructure is really meeting its commitment and its promise?
Perfect. Yeah, that really resonates. Thanks so much. And maybe just thanks, not just to you, Jennifer, but also to Janessa and Thomas for being with us this morning and sharing your insights and your experiences with us this morning. I think it's been super insightful. And maybe with that, I'll pass it back to you, Joe, if that's okay.
Perfect. Thank you so much, Franz. Yeah, just to echo what you're saying, that was an incredibly insightful, really interesting presentation. So thank you to all of our panelists. While you have been speaking, we have had some questions through. So I'm going to put these to you now. Whoever would like to answer them, feel free just to unmute and give your insight into it. The first one we have is from Peter in the chat. If I am interpreting your question correctly, he is asking about the commercial standpoint and the commercial side of all of the operations and everything we've talked about. In particular, looking at sustainability. So he is asking how, with CRH and how it promotes and how it applies AI into your business, is this having an impact on the sustainability question, either in a positive or a negative way?
Yeah, no, first of all, thanks for the question. I think Janessa, you touched on some of this already before with some of the mixed designs, right? And how we're trying to optimize it from a sustainability perspective. Do you want to maybe expand a bit on that?
Yeah. I'll hop in I mean I want to separate what we're trying to do from sustainability
Yeah.
and AI and commercial. I think that's a very hefty question. Thank you, Peter. We appreciate it. But ultimately, data is king, right? So the more information we have, the better positioned we are to utilize it. Now, I will say on the sustainability side, when we increase circularity, whether it's in concrete or whether it's in asphalt, and we start to think about SEMs, biorejuvenators, more mixed design. All of that will reduce our embodied carbon. And then when you bring in the AI technology piece of that, now we're talking about plant optimized temperatures, so production temperatures, energy reduction. And that does obviously impact what we do. In addition to that, we spoke about the AI nature, the sensors that we can place and embed within our production spaces. This is not just initial data, right? We're getting data on green strength, we're getting data on critical fail paths, and that's minimizing the rework, which I mentioned before, that has to go into some of this and in our construction process as a whole. So I think from a commercialization standpoint, we are definitely using AI technology right now. We are using predictive algorithms and methods to really maximize what our capabilities are, both from a material standpoint and from a construction speed and laydown standpoint. And all that's coming together to allow us to be more predictive and more responsive to the needs of our customers. Hopefully that answers what you were trying to get to, Peter. I know there was a lot in that question, but hopefully at least one of those nuggets
Yeah.
sat with you right.
Janessa, just to add on, I think it was a great answer, and it was a challenging question. The other side of what we do is think about within our operations how AI can drive more of that efficiency. So you think about the scale of our operations across the extractive side with quarries operating heavy equipment. Well, we're exploring emerging technology, understanding how AI can drive efficiency there. We're the largest road paver in North America. So we have to think about how we manage the equipment, how we reduce the idle time. That again has a direct impact on our carbon emissions. But it doesn't stop inside the house. I also partner with and work with a number of major GCs that operate on a global scale, understanding, what lessons we've learned through the heavy equipment side, what can they apply to their construction equipment, and all of that then starts to trend into the future of construction, which is around semi-autonomous and autonomous capabilities. So it's something we're doing to understand ourselves, but we're also partnering with our customers downstream to help them better understand the potential impact.
Yeah,
Awesome. Thanks,
really.
Thomas.
Yeah, thank you, Vance. Yeah, no, perfect. Really good answers from all of you there. Thank you very, very much. I think we have a little bit of time to get to some other questions here. So Thomas, you just mentioned about partnering with other companies and other industry players. Would anybody like to kind of delve into that a little bit more about how CRH is using partnerships to kind of enhance what they're doing a little bit?
I guess that falls to me because that's my scope, right? Um, No, look, it's a fascinating area. I think one of the things we've found is that there is a big motivation to solve some of the challenges we've been talking about on this call. I like to break it down into kind of the different phases where we have the potential to collaborate and influence outcomes. The first is on the design phase. So a number of designers, both external and then in-house design capabilities that exist in, the hyperscalers, they're approaching us trying to understand what is the potential for innovation as it relates to decarbonizing the project, to thinking about alternative uses of materials, to thinking about recycling or reclaiming materials. So we look at what Janessa talked about with reclaimed asphalt, or can you have recycled aggregates, so concrete as aggregates. These are some of the conversations we're having to help the design firms and the design professionals understand, one, what is possible, but then secondly, helping to provide materials for testing purposes. So part of moving the industry forward and part of advancing standards is actually demonstrating the performance of these emerging materials. And so we partner very closely because we have material science capabilities, we have testing capabilities, but we have to work with these experts to promote the use and adoption in industry. That's the first side. On the construction side, if we keep that same vein, a lot of it comes down to how do you drive the adoption of new materials? Again, it's making available our technical expertise to those individuals to understand what are the workability constraints. As we think about durability, what are the performance metrics that we have to understand? When we talk about, Jennifer talked about water management and bringing in new capabilities there. Well, can we use the insights to help understand and develop the stormwater management systems that are unique to the characteristics of that project? And when we do that, how do we think about replicating aspects of that with the customer? So that's also key, replication and scale. Finally, with the owners, more and more they're building in-house capabilities and they're wanting to partner early because for them to take certain decisions, they have to understand that the capacity exists in the market. And so, Franz and I and others have a number of conversations with large customers to understand if we promote the adoption of new solutions or innovations, is the capacity in the market to actually satisfy that to de-risk delivery? And again, we can confidently speak to that because we operate across more than 4,000 locations globally, across almost 300 operating companies. So that's where the conversation shifts to scale, and scale really does matter in this context. So yeah, that's how I think about partnerships. And of course, there's much that sits behind that in terms of governance and structuring it and putting metrics against it. But we try to approach it as, a mutually beneficial relationship.
Yeah, maybe one thing I'll add to that, Thomas, I think is, and I think you touched on it in the beginning, I think is the trust component, right? I think the idea of the partnerships is, when you collaborate together early on, you have to share, right? You have to share which projects you're working on, what the timelines are, and the sooner you get the people together across the value chain, the better you can manage those timelines and manage those projects, and that's why we're seeing a lot of the value being added through the partnership model.
I wanted to add too, I mean, when we talk about partnership, it's not just, how we partner with our customers. It's also the expertise and the relationships and partnerships that are brought to that. And so at CRH, I mean, there's a few different ways that we're partnering externally to hopefully benefit our customers as well. That would be from an association standpoint, anywhere from safety with NIOSH to even, academic institutes like Purdue, Auburn, UTA, AASHTO for governing and testing. And then we've got the associations for the industry standards, NAPA, to name one in particular. And all of that expertise, all of that inter-industry discussion, that also comes to play and that builds our capabilities. And then, looking more externally, we also have great advancements in partnering with startup businesses, new technologies, entrepreneurial ventures. We have a whole space dedicated, not only in our industry, but also in our company to exploring these relationships, to saying, is there something here we're not seeing? Is there something that we can develop? We have a lot of in-house expertise. We've got the labs, we've got the materials. And then when you start bringing in somebody who has the business vision or the innovative idea of something we've never thought of, we have the capabilities to test that, look at it, develop it, and ultimately bring it to market and scale to our customers. And I think that's a critical distinction, is all of these factors that are external to the relationship of us and our customer, they also come into play on the potential benefits or the innovation that's being created and the value that's being created in potential data centers like these.
Thanks. That's a great addition.
Okay, super. Thank you so much, everybody. We are swiftly approaching time, so I just want to throw out one more chance. If anybody wants to add any concluding statements, anything else that you'd like to add before we finish? No? Okay, well, all that's left to say then is thank you so much to everybody who has joined us for this. Thank you to all of our panelists for all of your fantastic insight. If any of the viewers would like any more information about all the stuff we've talked about, then obviously you can go to the CRH website. If you would like any more information broadly within the data center industry, you can also have a look at Data Center and Network News. But in general, thank you again for coming, and I hope you have a lovely rest of your day. Thank you, all the panelists. Thank you.
Thanks,
Thank
Jeff.
you.
Thank you.